is one of the past paper questions from the CCEA past paper from February 2022, I think it is. It's just one of the practice papers, and this one's on stats, and it's the correlation coefficient involving the hypothesis test. And so let's take a wee look at what's being asked. Now I've already written out the answers to this, so we'll just kind of be talking our way through it. But let's see. So table below shows the melting points and boiling points of 6 alkali metals. This is them here. John's a chemistry student. He calculates the product moment correlation coefficient between the melting points and boiling points of these alkali metals to be 0.8993. He decides to carry out a one-tailed hypothesis test at the 0.5% level of significance to test if there's a correlation between the melting point and the boiling point of the metals. It then says identify the null and alternative hypothesis he should use. So we first of all want to define this then to be our product moment correlation coefficient, and then we do our H0. So our H0 is at P equals 0, and that there's no correlation between the melting point and boiling point. And then H1 is P is greater than 0, so as in we kind of think, you know, there's a correlation between, as the melting point gets higher, the boiling point gets higher as well. And so P is greater than 0, and that's a one-tailed test. Over the page then, I can keep this hidden to keep the surprise. So complete the hypothesis test. So what information do we know? We know that N equals 6, and we know that our R value then is 0.8993. So if it needs to be significant at the 0.5% level, if we go to our tables here, again these are in your formula book, so 0.05% level, and our sample size is 6, is 0.9172. So if it's significant then, and if there is a proven correlation at 0.05 at the 0.5% level, it needs to be over 0.9172. So that's kind of what I've written down here then as my next line. R needs to be greater than or equal to 0.9172. Hence, there is insufficient evidence, because 0.8993 is smaller than that, to reject the null hypothesis and accept there is a correlation between the boiling and melting points of the 6 metals at the 0.5% level. Finally then, John is surprised at this result in part 2. Explain to John what change he could have made to this test to have achieved a different outcome. There's a couple of different things. So we need it to be bigger than 0.8993. We want 0.8993 to be significant. So even if we change then to the 1% level as opposed to the 0.5% level, that would make a difference. The other thing is, I'm not quite sure if they'd accept this answer, but he's tested it for 6 alkali metals. Even if he tests it for more, it's because the sample size is quite small. If there's only 6, it isn't kind of quite proven as much. So if he kind of did it for more, then that, I think that would kind of come out. So even if you kind of check and see what it's going to be for 7, we're down there at 87% now, and our result was 88. So either of those two. Just to tell you exactly what they have then in the answer booklet. A significance level is the probability of incorrectly rejecting the null hypothesis. In this case, the significance level is very small, so the 0.5% is a really small significance level. If you use the 1% level of significance, as we said, there's sufficient evidence to reject the null hypothesis, and so that would work, which is effectively then just what we say. So change the significance level or test more metals.